Hey everybody, welcome to episode 12. This is a quick one. First of all, thanks for all your help on the one I put up last night. And no, the radio's not working yet, but I'm pretty close to getting it there, I think. So let me tell you a couple of things here. You had a couple of questions. First of all, what is this wire? This wire goes to the filament of the 1U4, and when I was inspecting it, I noticed that the insulation was cracked, so I removed it and replaced it with this jumper wire. That's all it is. So I need to take that off of the socket, and that wire doesn't belong there. So that's not the cause of the issue. There was also a couple of comments that I put a little too much attention on the power section because I really didn't have full load. And while I think that's probably true, if you look at the schematic, you'll notice that they're calling for 130 volts here before it ever gets into the circuit. Right? Let me see if I can get that a little closer. I don't know if it's going to focus. But basically they're saying 130 volts coming right out of the diode. So in my my belief, that should be 130 no matter what, if there's load or no load. All of the load's going to occur afterwards here. So I'm going to leave that for now, but if I have a problem when I get it running, I'll change it. So a couple of things I learned last night about this couplet, right? This thing right here. So I didn't know it was called a couplet, first of all. And if you look at the way this thing was designed, let's see if I could show you this really close. You'll see that the wires are just all over the place, and it wasn't done very neatly. If I see if we could see this a little bit better, you see that, like, for example, 6 and 7 here are kind of like really close to each other, and this thing was all over the place and spaghetti wires. And I tested it, and there was actually an open resistor. And it was the 3.3 meg resistor, which is right here. Label it as D. This resistor's open. So I definitely had a problem with the couplet. So there's two things I could do. I could try to find one, or I can build my own. So I've decided to build my own. So what you see here is a new couplet. And here's the 9 wires that come out. And I haven't trimmed them yet, obviously. But I went through the schematic very carefully and wired all these components in. There's 4 resistors and 5 capacitors. All right, and on the back, you'll see I've got a bunch of jumper wires. And the next thing we're going to do is we're going to gator wire this into the radio and see if it works. If it does work, I'm going to use that stuff that they use to coat tools with. I think it's called Coat It or Dip It. And I'm simply just going to dip this in. It'll be covered in rubber. I won't have to worry about it. So very simple. I am going to trim this board as well because it's a little big. And this board will fit right in here just like the other one did. Free bird if anybody wants one. So so that's where we are. So I'm going to gator wire this thing in. Let's see if it works. I'll be back. Okay, I have the couplet gator wired in. I'm just going to do a little test without power. Okay, that's my audio generator. I'm going to turn up power. See if we get radio. I'm monitoring my B+. And my B+ is currently at about 90 volts. Which looks right to me, by the way, just to show you. Coming out of the top of this 1R5 tube, I'm supposed to have 85 volts coming down. Right here. That's my B+. Alright, there's a little bit of a resistor here, so it'll change. So I still have nothing, but let's see if I get any audio now when I touch pin 6 of the 3V4. No, let's try pin 5. Hold on, I need to check my connection. Let me be right back. Okay, I've got my connection in the right place. I had to put the negative side of the audio generator to ground. I didn't have it in the right place. So let's check pin 6. Nothing. Let's check pin 5. I don't know if you can hear that. It's very faint. Very faint. And that's on pin 2. Pin 5 is very faint. Let's turn the power off. Now, why am I getting it on pin 5? Let's see. Pin 5 of the 3V4. Right here. Pin 5 is the center tap of the filament. Interesting. Well, probably because I'm going directly to chassis ground. That would explain that. All right, so back to the drawing board for me a little bit. So what I'm going to do, given that I've got all this wires cut out of here, this is a great time. Let me remove all these gator wires here. This is a great time for me to change all these resistors out in here, and I'll show you why I want to do that in a moment. Let me just get these out of here. Okay, so taking a look down at these sockets, right there. Let me make sure this is in the right place. Okay. So you can see that I've got some pretty old resistors here. There's one that's buried in here. I've got a Glauber solder over here. This one I've already replaced. This one is very old. There's one buried under here. So this is the right time to change all this stuff, and this is this is the right time to do it, and that's what we're going to do, and that will maybe help me solve some of my problem as well, but we shall see. So that's going to be the next step here, is for me to clean all this section up, wire in this this new couplet after I get it coated, right? This thing here, and then we're gonna continue the troubleshooting. So I'm also going to pull this back. Clean up this wire that you noticed right here, and that's going to be the plan. So I'll shut this off, and I'll give you back a little bit of progress when I'm ready. Thanks. By the way, here's a design for a signal tracer that you use with a guitar amp. Carl and Bill, you guys mentioned this. Very simple. I'm going to build this. So it's basically a guitar plug, goes through a 2.2 meg resistor. There's a germanium diode, 1N34A, and there's a RF and audio switch. And down here you have a 0.47 and a 0.1, and it comes up here to a probe with a shield. So I'm going to build this. I have a lot of guitar amps, so that's easy, and I'll use that to help with the troubleshooting. Be back. Okay, so we've built our signal tracer. This is the diagram that you see here, and here's the product. I have a switch for RF and audio. On one side, I have a 1/4-inch jack that'll go into my guitar amplifier, and on this side, I have a probe, and it's got a nice little ground lead hanging out of it. So, once we get this this radio, and I get that the component put back in, this one, the couplet, I think is what it's called again. We're gonna test this thing out and see where my signal is. So really cool, really simple to build this thing. Okay. See you in a bit. Okay, just an update here. So in order to start to clean this radio up, I actually looked at these sockets, and there was just a lot of solder all over the place. So I actually stripped them all down, and I'm redoing this entire section here. Nothing prolific. I'm just going to make sure that all of my filament lines are good, all the resistors are going to be replaced. I'm still wiring in this electrolytic cap, and I'm still connecting this this 1U5 tube here. And I'm not going to rewire the whole thing, obviously. Let me pull this back a little bit. I'm not going to rewire the whole thing. That would be silly. But I am also going to clean up this 1U4 tube. That's a mess down here. So we're going to make it a little bit neater. I also took the opportunity to clean it. And then the other thing I'm finalizing is the couplet. Right, this is the couplet that I took out that was bad. I showed you this prototype earlier that I made, but I just didn't like it. It was a little too bulky. So I've made this one, and this is the right one I'm going to use. And what I did was I ordered a piece of 2-inch wide heat shrink tube that's going to slide right over this like that, and we're going to put a little heat on it, and I'm going to have a nice sealed couplet. This has all been ohmed out and checked out, and everything is where it needs to be. Very minimal design, as you can see. Not a lot going on here. And I used a special board here. You'll see that there's actually 4 sections. There's a rail here. There's a section of 4, 2, 4, and another rail down there. That was really helpful to get this thing wired. So there's my couplet. And once I have the heat shrink tube, I'll be able to insert this thing in the radio where it needs to go, down here. So so making some good progress there. And I'm just going to continue this wiring. And then I'm going to use my signal tracer, which I showed you, I think. I don't remember because I've been working on this video for a few days. So I actually did make the signal tracer. It's right here, RF and audio. One end has the plug which goes into the amplifier. The other end is the probe right here with a ground. And this is what I'm going to use to test it. So I've built that that signal tracer. So we're on our way. So I'm going to put this video up now because I got some work to do here. There's not much I'm going to show you that you don't really know. And then we're going to proceed. So the main thing for me is make sure the filaments are all right. Make sure that this power section over here is where it needs to be, right here. Get this all cleaned up appropriately. I'm going to put a smaller cap in here. Actually, this one is like a 450 volt cap, and there's like 100 volts going through here. So there's really no reason to use a large cap like that. So I've got a smaller one I'm going to put in. But that's it for now. So if you ever want to build a couplet, don't be scared. It's pretty simple. This one's a little bigger than this one, but it's still going to serve the purpose. Okay, everybody, that's about it. Sorry if I give you some contradicting information in the beginning of this video, but I was still learning. All right, guys, take care.